So we know that we can use the equation that we saw in terms of the free energy of a reaction. But what if we're actually thinking about the free energy of the formation of a particular molecule? So that's actually completely analogous to thinking about the enthalpy of formation, or it's basically the standard Gibbs free energy of formation. So this is talking about forming a mole of a compound from its most stable elements, from its elements in their most stable states at pressure of 1 bar and at room temperature. So we know that we can tabulate it just like we tabulated delta H of formation, but we can also tabulate it from this reaction here, which it looks like I already told you this reaction, which I did, but I told you a more general form, which was for the free energy of a reaction. This is the free energy of a reaction, which is the formation of a certain compound, and this is the free energy of formation equals the enthalpy of formation minus T delta S. So let's think about why it is important to be thinking about these changes of free energy in terms of forming a molecule. And it's important because the delta G of formation is actually a measure of how stable or unstable a molecule is relative to its elements. So for example, if something is really stable relative to its elements, we can think about whether delta G of formation should be negative or positive. So let's have you do one last clicker question here and tell me, what do you think if delta G of formation of actually forming a molecule is going to be negative? Would you say that the compound is going to be stable or unstable relative to the elements that that compound is made up of? All right, let's take 10 seconds on this. Okay, interesting. So this is going to be another tiebreaker for us. So let's go back to the notes and think about this. So it turns out that it's going to be stable relative to its the compound is stable relative to its elements. And the reason for this is if you think of the reaction of the elements forming the compound, if the delta G of that reaction is negative, that means it's going to spontaneously form the compound. It's going to go release energy when it actually forms that compound. So that's another way of telling us that the compound is more stable than its elements. So conversely, if we have delta G of formation being greater than 0, so delta G of formation is just delta G of the reaction where the compound is formed, then what we find is that it's thermodynamically unstable relative to its elements because instead of releasing energy in that reaction, you actually have to put energy into that reaction in order to make it happen. So delta G of formation can give us an indication of whether we have a stable or an unstable compound.